So again, this is the last section of our conics unit. You're going to learn how to classify conics. And it's pretty straightforward, okay? Take a look at these 4 different equations that are in standard form for a circle, ellipse, a parabola, and a hyperbola, okay? What are some distinct differences of any one of those conic sections?
Hyperbolas are being divided.
Okay, so one big difference between their standard forms is ellipses and hyperbolas, like they have fractions within their standard forms. That's one good observation. What else?
The parabola only has one square term.
The parabola only has one squared term compared to all the other ones. All the other ones, both of their variables are being squared. That's good. What else do you notice?
For the parabola, you have the y on the right side.
Okay. So we have, oops, change that over back to draw. We do have that difference there. You got x equals versus a y equals. Any other distinctions?
Ellipses and hyperbolas have to equal 1.
Ellipses and hyperbolas have got to equal 1.
Ellipses, you add the 2 together, and then hyperbola, you subtract them.
Ellipses has an addition, hyperbolas has a subtraction, okay? So really and truly, like if I were to give you these equations without actually having the names in red beside them, I'm pretty sure you could tell some of the differences and actually tell me what they were, okay? But a lot of times your equations aren't going to be given to you in standard form, okay? They'll be given to you in that long form where you have to complete the square to put them into standard form. So when that happens, it might not be as easy to see what they are, okay? So when you're classifying conics, this flow chart here will help you in determining which is which. So the first thing you should ask yourself is if both terms are being squared, both your x and your y are being squared. Because if they're not, if your x and your y aren't both being squared, then you know it's automatically a what? It's going to be a parabola. So if it's a no, you know it's going to be a parabola. However, if they're both squared, then what you want to look at is your x squared term being or your x squared term and your y squared term, are they different signs? In other words, is your x squared negative and your y squared positive, or vice versa? Is your y squared negative and your x squared positive? I think I should say the same thing twice, but y'all get what I'm saying. If they are different signs, that means it's a what? It's a hyperbola. But if they're not, then that leaves you with, okay, this either is going to be a circle or an ellipse. Again, I'm not talking about from standard form. I'm talking about from that long expanded form, okay? If the x squared and the y squared have different signs, or they do not have different signs, they're both positive, then you need to look at the coefficient, okay? Is the coefficient of both your x squared and y squared equal? Because if they are equal, it's a circle. But if they're not equal, okay, this one technically is like 1/25. This one's technically 1/4. Then it's an ellipse. And that is how you classify your conics. Questions? Can y'all make it out? Okay. It's a tad bit blurry. I didn't figure, like, as I expanded, it was going to look like this. On your desk, using your flow chart, tell me, what conic is it on your desk? What is it? Very much so. Why? Only your y's are being squared, not your x's. Very good. Here's the next one. 20 seconds. You. Which conic is it?
Hyperbola,
How do you know?
because there are different signs.
Exactly. There are different signs. Even though their coefficients are equal, the fact is that that's a minus. That minus trumps the fact that the coefficients are equal. Very good. Here's the next one. I'll do this one, okay? So one thing is that this one is in the expanded form, okay? However, it's not necessarily ready that if I wanted to put it into standard form, I couldn't do that with that negative x squared on the other side from everything else. So if I added it over, so then that way everything was on one side, I see that one, both of my terms are being squared. Two, they are both the same sign, they're both positive. Three, they both have the same coefficient, which means this one is a circle. This one was a circle, okay? So don't let the fact that they're on opposite sides throw you off. Bring everything to one side like you would if you were to put it into standard form. And then look at it from there, okay? Here's the next one. Which one is this? It is ellipse. They're both being squared. The sign is positive, but the coefficients are different, hence making it an ellipse. Very good. Last one on these before we move forward. I guess you should make sure to specify that when you are using the flow chart, it might be helpful if both your x squared and your y squared were on the same side. Because I'm starting to notice, at least with you guys online, some of you guys are getting mixed up because when one of the square terms is on the opposite side of the other, you're looking at them how they are. Get both your x squared term and your y squared term on the same side and then look at the coefficients or the sign, okay? Which one was this? Which one? Hyperbola. Okay, I thought I heard parabola for a second. It is a hyperbola because if I do get my square terms on both sides, this will be 7y squared minus 6x squared. So minus, which indicates a hyperbola. Real quick, more specifically, since we did talk about hyperbolas yesterday, is this, oh, hold on. Okay. There we go. Since we did talk about hyperbolas yesterday, is this a vertical hyperbola or a horizontal hyperbola? It is vertical. How do you know? Because your y is first, and on top of that, your y squared term is positive. So technically, it would have been y's first, then your x's, okay? That's how you would separate them to complete the square. Okay, so this one would have been a vertical hyperbola. Questions on classifying?
No, ma'am.
Okay, then let's combine some things with classifying as well as making sure that we are still good on converting things into standard form. This one I'm going to do with you guys, with your assistance, and then you'll have a few to do on your own. First off, what type of conic is this? It is a parabola. I only have my y's that are being squared, no x's. Okay, so if it is a parabola, I want to make sure that my square terms are on one side and then my non-square terms on the other side. So remember, we're going to keep our y's on the left. We're going to go ahead and move everything else on over to the right. Plus 49. I could. Yeah. Could move my y's to the right. All I know is I do need them separated. When I complete the square, I got to make sure that this leading coefficient is 1. So what do I need to just add -2? Factor it out. That leaves me with y squared. Is it plus 10 or minus 10?
Plus 10.
It would be that plus 10y, because if I take out a -2, -20 divided by -2 is a positive 10. I am going to need to complete the square at this point. When I complete the square, I will take half of b, which is then I need to square it, which is, now I know that 25 is going to go here, but what is going to go on to this side?
-50.
It would be -50. Remember, anytime you're completing the square, the number you add to the other side, if there is a GCF factor, you multiply it by the number in the box, and that's what gets added on over. That is going to be a -50. This factors down to be -2y, what? Plus 5 squared, and this turns into a -x minus 1. Not in standard form yet. I can't have this -2 in front here, and x can't be negative over here. So what should I do? Divide by -2. And then what should I do on the right? Pull out a -1. I'll break this down into the pieces. I'm going to pull out a -1 so that way x can be positive, which it needs to be. Then I'll divide by my -2. So my final answer in standard form is this. Here's the first one that I want you to practice. What conic was it? It was a circle. Both terms, both your x and y are being squared. The sign is the same and the coefficients are equal. So when you went to go complete the square, you took half of 6 and squared it to get, and then you took half of -2 and you squared it to get, and then you added 9 and 1 to the other side once you complete the square, subtracting that constant over, so then that way you could work from there. Standard form would have been x plus y equals 1. So even though this does equal 1, it's the fact that the coefficients are equal. That's why it's not an ellipse. What's the center of the circle? Very good. What's the radius? Awesome job. Questions on this? Everybody understand why it is a circle, not an ellipse? Here's your next one. Online, what conic is this? Online.
Hyperbola.
It's a hyperbola, okay? And because it's a hyperbola, there's a vertical type of hyperbola or a horizontal hyperbola. Since you did put it into standard form, or I hope you put it into standard form, is this one vertical or is it horizontal?
Vertical.
This one is very much vertical, okay? Because for one, your y's are the positive one. It's your x's that are the negative. So that there lets you know. I don't have to complete the square for the y's, but I do need it for the x's. So I factor out a what? A -9 to get x squared plus 8x. What's half of 8 squared? Well, what number am I adding to the other side? Didn't hear you. So the right side becomes a +9. And on the left side, this becomes -9. Factor this. What two numbers, if you didn't essentially say what two numbers multiply to give you 16 that add together to give you 8, or what was the number you got when you took half of 8?
4.
That's the number that always goes into that parentheses when you complete the square. The last thing I need to do, because this is a hyperbola, is it needs to equal 1. So what do I need to do from here? Divide every term by 9. So I'll have a y squared over 9, x plus 4 squared over 1, or just x plus 4 squared, is equal to 1. This is a vertical hyperbola. What's the value of A? 3. What's the value of B? 1. What's the center of the hyperbola? Somebody online, what's the center of the hyperbola? Somebody online.
-4, 0.
Yeah, -4, 0. Make sure that you do not mix these up. Even though the y's are first, remember it's still HK. H is with X, K is with Y. And last thing I'll ask from the lesson from Monday, what is the eccentricity? Find my eccentricity. Remember, to find your eccentricity is the formula C over A. And for a hyperbola, it tells you how uncircular it is. So whether or not it's gonna be like one of those super, super wide hyperbola branches, or they're gonna be like really, really skinny. The value of C was what? It was the square root of 10. And A was 3, because remember, 9 is equal to A squared. 1 is equal to B squared. So when you use that formula of C squared equals A squared plus B squared, you are just plugging in those values from your standard form. Now squaring 9, I think some of you guys might accidentally squared 9, okay? But that is how you classify conics.